Good afternoon. I know it's late in the day and people are probably sick of hearing about governance, but we'll talk a little bit about it, and we'll talk about our solution to the problem. So before we get started, we just want to make one thing that's a little bit more clear. There's a bit of a typo in the speaker documentation, and it lists us as the CTO and the senior director. As you can tell, that is not the case. So we just want to make sure that's cleared up right at the beginning. Just a little bit of an agenda of what we're going to be going through today. We have a handful of use cases we have gotten from our business partners, Dan and myself, as well as our extended team support our data science organization from a tooling and infrastructure standpoint. And they've come to us with some very interesting challenges in the last year around finding data, being able to track data, being able to look at data, and being able to not abuse the power that comes with a big data environment. And we're seeing a lot of that starting to come up more and more as people get more familiar with the tool. It becomes a lot easier for you to put in things repetitively, things that you might want to just see very quickly and easily that you wouldn't need to necessarily run over and over again. So a little bit about Aetna, if you aren't aware of Aetna. Aetna is an insurance company with over 46 million members, multiple different lines of insurance being served, as well as, as if you were coming from the Atlas presentation, we're relatively mature in the big data space at this time, and all of the data related to these lines of business we have in one place at this point. So we're trying to create that data lake concept. And with that comes some very obvious challenges. So those challenges that we're seeing from the data scientists, and these are our three big use cases that our application that internally is called the Mosaic project, are designed to alleviate. The first big one is that data scientists are spending an inexorbitant amount of time trying to find the columns they're looking for to do variable selection. Like it says, on average, our data scientists are spending 80% of their time. When you have multiple petabytes of data that all lands in one place, and it's coming from separate lines of business, and you have one unified organization, you generally don't have the breadth of subject matter in that one organization to be able to find all of the data that you're looking for very quickly, so you can get to the meat of data science, to the modeling process, and to the results side. So, we've taken that as our first big use case. Our second use case is around the shape of the data. We have thousands of queries run a day, and of those, over 75% are being run as investigative profiling queries, and we'll get a little bit into that in a little bit. And then the last one is the actual transformation of the data. And again, if you're coming from the Atlas talk, this is that Lineage component that they talked to. And then the fourth thing that we don't have listed here, but is kind of the agenda, is that we're going to do a live demonstration of our internal product. This is our actual UI that our customer base uses to find their variable selection, as well as do their lineage tracking and their profiling. So for the first one, I'm going to hand it over to Dan Marquardt, who's an infrastructure developer with us, and he'll go through the section about finding the data.
Thank you. So when asked of one of our data scientists, how much time do you spend trying to find the information you're looking for? Now, you can imagine at a health insurance company that's been around for many, 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 many years, we've acquired many different companies and systems, and they all kind of coexist together, and all of that data now lives in a data lake. Now, there's thousands of tables that we have, and you have to imagine, well, how are you going to find any of this information? So some of the challenges that we asked of our data scientists, so what do you spend all your time doing? Of that 80%, they try to find things in HDFS and Hive. And Hive requires the manual traversal of schemas to find tables and columns. So a lot of these are based on name. Some of the documentation, while it exists, with more tables means it's harder to update. It takes a little bit longer to work through, to parse through, to manage. And you have to go through the Hive CLI, or even just Hue, a little bit simpler, but still very difficult. Go through and actually look at all of your tables and all of your columns. You have to run those manual queries yourselves. You have to look through everything yourself. There is no good search facility to actually find any of the information you're looking for. Hive, if you want to, HDFS, if you want to go through the file system, you have to go file by file, directory by directory, looking for all of this stuff. And as I said, the external documentation is a little bit harder to maintain once you have all of these systems coexisting together. And yes, you can build structures around them, you can build consistency around them, and you can adhere to it, but it is still a lot of information. And there's no practical means to add additional metadata. Things like, is this a column PHI related? Is there PII in this? Is this related to a particular line of business? You don't necessarily know, and for a lot of our new data scientists who haven't been with us for very long, or even someone like me who hasn't been with the company for very long, it's hard to understand where any of this is and where it came from. We're not seasoned veterans. We weren't around for the acquisitions. We don't know. So some of our solutions that we came up with were to capture the Hive and HDFS metadata at runtime and store it in a repository. And what we did with that, using actually Atlas Atlas presentation spoke to this a little bit with the hook concept. So the Hive hook captures all of the runtime metadata about the queries you're running and puts it into a repository. We also capture HDFS metadata and put that into the same repository and collate it in the same way. And we've provided an API to interactively search and query this metadata, very much like a Google search, which you'll see later in the demonstration. So on top of that, we've also provided an API to enrich the logical metadata with some business context, things like that PII and the PHI that tools like Atlas are now starting to pick up and also do. So just a bit of a quick delineation of some of how the repository is structured. So we have the physical metadata and business metadata, effectively. The physical metadata is comprised of the Hive, HDFS, and Scoop raw executions, the things that happened at sort of that low-level atomic level. And those go into the physical metadata repository where we sort of chain some of the information together to logically represent the flows of information and how things have transformed. And on top of that is Apache Atlas, effectively, which is capable of managing all of the business level metadata, at least how we're planning to use it. And sort of on top of that, both of those metadata repositories, there is a search facility that allows us to query that interactively and get the information that the data scientists are looking for through a simple query, just a search engine, just a search page. And now I'm going to hand it back over to Dennis to talk a little bit about how we've tackled the challenge of finding out the shape of the data.
So, the problem, like we discussed a little earlier, is that there are a lot of queries being run. On average, we have, in our primary environment, about 5,000 queries run a day. And of those, 78% were things that were statistical in nature, but statistical profiling in nature. What's the average of this column? What's the min and max of this column? A piece that regularly goes into that selection process for data science, looking at that shape of the data. And we were seeing a lot of the same queries being run by the same team over and over again on the same column, because they were looking for the same variable. That variable was, some indicator column, or they're looking for a specific ICD column, and they were running distincts against it and some categorical checks. And we saw this as a quick win for building an API around. So the two big challenges we saw in this space is there's some limited metadata in the Hive Metastore in regards to stats around columns, as well as stats around tables. But they're really only surface deep, and they're really only efficient for the use of optimizing queries. The other side effect of that is constantly having people hit this hundreds and hundreds or thousands of times a day is potentially disruptive to the production system. We were seeing originally in Hive server, in the original Hive server, and less so in Hive server 2, that if you had many concurrent connections to the metastore, you would actually impact the writing of the metastore by the concurrent jobs coming in later. So we wanted to create what is effectively a reporting layer on top of that. The other challenge was that there's a lot more to the data science variable selection process than just those very simple things. They want to see, what does the data look like? What's a histogram of the data? I want to see a categorical view of the data. So there's hundreds of other queries that are possible to run that not only help the person running them, but could help anyone on that table as well when they come back and look at it. So our design around this was to create a system for storing that profile. The storage of that profile is in a metadata repository that's part of that business definition, because to us, we wanted to make sure that we separated the logical definitions from what we consider business logic, so that the two are connected but not dependent on each other, because it would allow for the underlying layer to change without having to change the taxonomy and the properties that come from the business itself. And the second thing is to create an extensible framework for that. So part of the product is that we have the ability for data scientists to upload their own queries and say, this is now a profile, this is the outcome of that profile, I want it displayed with this visualization on the page. And those are all placed into the system and can make it so that any query that's been generated or run has a visual representation. So, first place you look is, and when you're searching for anything, we wanted this to be that Google-style location. So you go and you search first. Then you find out, oh, this is what it looks like. I might have all the data, I might not. I want to run additional profiles as well. And that is, our profiling component. So, as you come through that journey from the UI standpoint, and we'll get into that a little bit later, it's that second phase of variable selection. The first one is, I need a thing. What is that thing you're looking for? And the second one is, I want to see the shape of that thing. I want to be able to look at the properties of it. And then I'll turn it back over to Dan for our third use case, which is, once I find a thing and I know what it looks like, how can I guarantee that it is safe and good to use in the selection process to move on to your models?
Yep. So the last part is tracking transformation. So the data scientists want to understand how their data sets were derived. So a lot of people have probably asked the question, well, where did my data come from? It's living in this data lake, and we're doing all these exploratory transformations and aggregations, and after the umpteenth person has actually seen it, it lands in a table somewhere, and you want to understand, where did this come from? So some of the challenges with that are documenting transformations is an entirely manual task, and it cannot be done at scale. As I alluded to before, we have thousands of tables, some of which have thousands of columns. You mean to tell me that someone is going to sit down and document each and every single one of them every single time with an insane amount of consistency, accuracy, and depth of information? Maybe. But when you have that many tables and that many models, it becomes that much harder to do. And we'd like to make it easier so that we have our data scientists doing less of that and more actually playing with the information, understanding it, letting the tools do some of that work for them. On top of that, there's no mechanism for auditing some of these data pipelines. So when you do these transformations in Hive, there's nothing that tells you where this column came from and which columns did you aggregate to actually come up with this final result, which is especially important in things like financial reporting. So if you generated something in Hadoop for quarterly estimates, say, you may need to know or produce information about how it got there. And identifying data quality and provenance is also a manual effort. A lot of times just talking to the person next to you going, hey, you created this table, I see you're the owner, where did it come from? Play the game of telephone enough times, it gets a little difficult. So the solutions to some of this is that we came up with is to leverage the metadata captured for search to construct the flow of the transformations. So with each of these transformations getting created, this is sort of goes back to the Lineage part of Atlas, we actually captured these same transformations and created sort of their meta representations and was able to link them all together in a logical flow so that you could actually see where your data came from and where it is now or where it went after a certain point in time. So we've also provided an API for interrogating these transformation executions and for actually obtaining that sort of tree in either direction of sort from where it came from and where it went. And yeah, okay, I covered that. So that is sort of the initial piece of the Mosaic project that we've come up with. So search, data profiling, and what is effectively Lineage. So basically search, if you know how to search Google or Amazon, you can search this system. Very easy for entry. Profiling, the profiling piece stores the metrics about the data you're browsing, and that's extensible enough for people to add their own so that you can add your own personal flavor to help some of your teammates. And also the lineage piece. You need to know where it came from, where it went, and it's ultimately just driven by the tool. There is no manual interaction involved with the lineage component. And with that, I'm going to turn it over to Dennis for a quick live demonstration of the Mosaic project.
That is zoomed way in. Okay. All right, so like we already alluded to, we wanted this to be a low barrier of entry into the Hadoop ecosystem and finding the data you're looking for. So you're going to see a lot of familiar design patterns in terms of what is usable out in the industry. Our big first challenge was how do we do a search of multiple different object types in a way that seems intuitive to the user? The real easy answer to that for us was an Amazon-like search where everything is compact and comparative on a single screen. So I'll use the traditional example tables that come with a lot of the systems for this, as well as some of the healthcare specific stuff a little bit later on. But for this, we'll search for, what is a traditional simple search object. Here you go. Where is the NYSE table? What is it? You get back a sampling of what that is. Right now, they're ordered by relevancy based on an amount of ranking under the covers that will return the thing that is most valuable to your search result in much the same way that Google or Amazon search engines accomplish that. So it bubbles up the most important and most used items to the top of the list as you go through. So to look through this data, you now get what we call our quick profile, and this is the really just skin deep. What does the data look like? Where is it? Who owns it? Where does it live? When was it created? So that you can get a nice quick view of the entire piece of data, and you can shuffle through and find the exact one you're looking for. Once you find that piece of data that you're actually going to go a little bit deeper on and go into that profiling, you go into the full profile. The full profile gives you a much deeper dive into the information, some high-level stats, and a display of what the actual distribution of this table looks like. Given the stock that it is stock data, everything trades, for the most part, relatively low. As you can see, prices are towards the left end of that histogram. And then you have your other quick variables, cardinality, as well as your min and max, some of the real quick high-level ones, so that you can decide whether you want to use this table or not. Another thing that we were seeing a lot of in terms of barrier to entry is how can I get the data sample of this data? So how do I, once I find a table, how can I make sure it's the right data? We provide a sample of the table data to this data. Yeah. And right now, it's really just the top of the data, so you can look and see if this data actually matches what you're looking for. There was a request from our data scientists to say, well, the first 10 records is great, but the first 10 records isn't a representative sample. So we also have a means of creating an actual representative sample of that data as well, without ever having to go deep into the system and come out with, you don't have to go into the Hive CLI, you don't have to go into Hue, you can just look at the table here and decide whether that data is something you'd like to see. Another component that they asked for is the ability to add comments to the data. So a social aspect of the data. So this social aspect also goes deep into the search as well. So all of these transitive properties associated with the data can come back in the search result. So if I were to, go and search for, enjoy and pizza, you would end up getting the NYSE stocks table, and it would tell you this is why you got the NYSE stocks table, because there's a comment related to it. And the weight of those comments is dependent on the position that person has within the data org itself. So things of the nature of data stewards and data managers actually carry more weight when they put data into the system. Whereas some of the newer users, if you put in a comment to the extent of, oh, I used this in this model one time to do some exploration, not really as important as a comment from a data steward saying, this column came from this location and further up the chain. So we'll go into the third piece, which is that lineage component. We have a Medicare use case that we designed using just open source Medicare data for this purpose. So this is, again, sample data that's available. So if we go into one of these profiles, into the lineage component, you can actually see, let me bring that up a little bit higher on the screen. You can actually see where the data has gone and where the data's come from. So from left to right, you've got where the data came from. It doesn't go all the way back to, say, an external system, because all these tables were created specifically in Hive. If this were part of our production environment, you'd actually see off the left-hand side what external system it came from. So if it came from a DB2 source, DB2 system, if it came from part of our enterprise data warehouse, and when that comes in, very similar to the hook concept that is used within Atlas, we have a similar concept on Scoop. So those hooks actually will run at ingestion time, modify that data, and say, here you go, here's your upstream and downstream of that location. So that actually leads to, what are and then towards the right side, you're going with what happens to that data. So you can see the one we searched for here, which was hospital tech all med volume. So it's all the medical volume for hospital technicians. And everything downstream from that is aggregated models. So you can actually explore around this as well by moving them around and going to the profile for these pages as well. So the other component, and when we're talking about metadata and adding metadata, was how do we add additional business logic to these? So if I come over here to our attribute system, this is actually where that kind of that philosophical bag of stuff is. Where is all that traits related to this data? And this is how the system will know what you're looking for in additional regards, right? So you can say, I want you to give me all the tables, but I want you to give me all the tables that have PHI and aren't encrypted. So when you come to an audit point, you can say, oh, we still have data that's not encrypted but has sensitive information in it. Or you can say, give me all the encrypted information. Or in this case, give me all the information that Chris Heiser is the subject matter expert on. And these are, extensible traits. Looks like it was cut off a little on the presentation, but at the bottom there's an ability to add new ones. So you can just say, this is hospital data. So, you could have type vertical Medicare, and you save it. And you now know what vertical it's in, and that becomes an additional search facet as well. So it allows you to dig a little bit deeper into your data, and as you put more data in and the data socializes more, you get more and more data to search on. So, all right. And that is the end of the demo, so we can open it up to some Q&A. Other direction. So in terms of, so there's a couple prefaces before we go into the Q&A, and I know it's a little bit vague what we're talking about, deep or not too deep into. There are some components of this that we are obviously looking to go into the open source community with. Our interaction with the Atlas team and our co-development, actually myself and Dan are part of that co-development partnership. So many of the components that we're building in the back of this will be moving into the Atlas code base in terms of the Lineage component and the hooks being a little bit deeper in that vertical. And then obviously there's some of this that is that, a little bit of that secret sauce for internal. So if you got questions, go ahead and come on up to one of the microphones and we'll do our best to answer them. Yep. Go ahead.
So you guys come from healthcare, right? So you have a lot of experience with traditional data management, data warehousing, and all those elements that goes around governance, lineage, and how you track from the physical layer all the way up to the business layer. I was excited to see the Atlas and seeing what you guys are coming up with. In your opinion, when you think about what you were doing in the context of relational databases in the past, in terms of solutions like Informaticas and others in this space,
yep.
How far away you think Atlas is in terms of code base where you are right now? What are in your head, the top features that you want to see there based on your experience so far to help us to complement this whole ecosystem of governance?
Yeah, so much the way that Andrew and Venkatesh alluded to in the previous presentation, that Hive vertical and that Lineage vertical, much the way that we showed it here, is our driving force. When you're a large enterprise, when you're coming from that traditionally RDBMS-driven world, everything in your new system starts as if it's RDBMS. You're moving all of your data from tables into new tables. So for us, the big ones to meet our deliverables are around that space. We need to be able to say with certainty, the same way we do in our older traditional tools, in our ETL traditional tools, I can guarantee that this came from this path so that we can satisfy audit. Being a health insurance company that is publicly traded, we have 6 different audit organizations on us at any time. So everything from PCI to SOX to everything in between. So we need to make sure we can satisfy those requirements. One of the things that is unique to this product being developed in-house for us is we've worked closely with our audit staff and our compliance people to make sure that what we're producing is something that could hold up as factual audit, right? So we don't want to ever get to this point where it's like, well, here's the picture, and they say, well, I need to see the code, or something along those lines. So one of the components we're actually working on in the near future is a full audit package to go with this, where you can see from the standpoint of security and audit what happened. Give me one user, give me one user, give me one table. Whatever happens to this logical vertical, how did we get it to the state it's in now? Because much the same way that Atlas and our product are capturing all of that data, once you have all that metadata in one place, it's a very rich environment to find all of that extra data around it and make associations on data that you never could before, that were siloed off. Go ahead. Yeah.
First of all, I have to acknowledge that I don't know the Atlas product at all, so that initiative. But I know there's a project called Loom, Loom, L-O-O-M.
Okay.
Is anyone familiar, or I'm the only one?
Are you familiar with that?
No?
No.
Anyway, they also kind of try to make the metadata available now. So in the enterprise like yours, I'm sure you have other big enterprise metadata storage.
Yep.
So how do you work with that storage? Do you publish this information to that storage?
So, and that goes again back to the Atlas piece, right? So one of the core tenets of Atlas and our operating model is ODP, so the open data platforms, as well as the governance ready policy. So our system, being that we're so closely involved with Atlas, we're going to make sure that our system is gov ready, and we will consume and publish metadata between other gov ready sources. So all of that metadata will end up in one place. Same with ODP sources. So basically there's an API for you to come in and get the metadata, as well as API for you to push the metadata into, without having to have some special custom format or anything like that.
So do you store this metadata in Hive, or where are you storing the metadata?
So it's stored in a metadata repository. So that's, I know for the Atlas component, they store it in, I don't remember what the
They use it in Titan.
Titan.
They use Titan.
Yeah.
Titan.
Yep. So they store it in a graph database.
I see.
So
Okay, so we need to have the Titan infrastructure with Atlas.
yeah. So for Atlas, I know it's bundled with it, and I know that Atlas has it running against the cluster as well as in a standalone capacity. So in our journey to get to this point, we wanted to make sure we could run entirely on the platform, and make sure that everything was part of the HDP stack or supportable on the HDP stack.
So is it Atlas, sorry, last question. Is that for the physical metadata, is that Atlas also takes care of the physical metadata or only the business metadata?
So the components of Atlas, there are components of Atlas that do take care of that physical metadata. The one piece that goes with this is, we kind of started this about 6 months before getting involved with Atlas. So a lot of those hooks that are part of Atlas started as part of the side project at the time. So we took a lot of that code that was almost production ready in our eyes and contributed it back. So the Hive hook that is within that system kind of started as a theoretical thing in our R&D department. Right now we're working on a much more advanced version of the Scoop hook that we're getting ready to contribute back. Basically making it so Scoop functions a lot more like Hive. So there's a pre and post hook. So you can have actions happen before and after actual Hive, Scoop executions as well.
Sure. And I see you didn't separate the operational metadata. And it looks like you have captured that in the physical metadata layer.
Yeah, so for right now, that is to us physical metadata. We haven't had a need to separate it out independent of the other classification, so the physical metadata itself. But if we had to, we could separate it again. It just comes down to a classification. Sure. How many types of classification do you want before you end up getting too big of a sprawl of type of metadata on top of individual verticals?
Thank you. Thank you.
How do you deal with the concept of time? Things evolve, schemas change. How does that work in your world?
You want to touch that one?
Well, I guess schema as it relates to what?
So the schemas for your tables are changing over time. So you're collecting the metadata, the schemas are changing. How do you relate, columns to columns that may have been?
So part of that is through that lineage component, everything based on the individualized system sort of it's broken up out into modules. It was pretty clear as to how that was done in much the same way that Atlas works in that regard. What ends up happening is those raw executions build the representations of the raw pieces of information that exist, and it's picking up their transformation, so you know what it looked like when it started and what it looked like when it finished. So you can always be able to trace back exactly what happened and where it came from. With Hive, it's a matter of you parse the query, you look at the query, and you can interrogate where the information, like which columns you used to generate the final columns. So it's just a matter of piecing the entire query together and then matching it against what you have in the system already.
I was really asking something a little bit different, but I think it covers it as well. Okay, that's fine.
Okay.
Thank you. Yeah, go ahead. Just step up to the mic to ask the question.
Quick question about the data discovery part.
Sure.
One of our use cases to find out, do we have PCI or PI data in the data we have? I assume it's all about metadata, not to dig into the actual data, right?
Yep, that's correct.
Okay.
So right now that is a manual entry task based on our data management and our data governance organizations. We are looking to try to figure out a way to make it automatic, where we do some kind of check when the data is on its way through to say, hey, this matches a thing. But that's a much deeper problem than what we're trying to initially get out the door, right? So once this is out with our customer base and it's been out long enough, been out there long enough, we need to make sure that the components they want first are rock solid. But we are looking at various different encryption frameworks, as well as some automated tag generation during parts of the process. So in those Hive hooks and in those Scoop hooks, being able to say, hey, this came from here, so it means this. So being able to put a rules engine around those hooks so that if it matches certain criteria through the process, you don't need a human being going in and manually entering all this information.
Okay, cool. Thank you.
Anybody else? All right.
Thank you.
So, thank you for coming. We would love the feedback. So the feedback within the application, within the
Hadoop
Summit app, that feedback is going to go a long way to seeing what is viable to push out to open source and what the community is looking for. So if you want to give a rating and some conversation around that. Thank you.